for this, you remember back when we were doing sequences?
Yeah.
And we had, say, like a recursive definition?
Yeah.
Where they gave you the recursive definition for a sequence, they gave you the first term in the sequence, and then, comma, the rule to find each term after that, like add 5 or whatever it is, okay? So just as a quick review, and there's two ways, yeah, well, I can just squeeze it in here, it's not much. There's two ways to do this, right? Like, remember when we do like A sub n, it's the terms place in line, like the first, second, third place in line, right? So A sub n, or it could also be A parentheses n, right? Either way. So that means this is just the current term you're looking at, or any given term. The current term, or whatever place in line you're looking at. Like A sub 3 would be the third term in line, right? And if you want to talk about, say, the previous term, A sub n minus 1, right? So one place back in line, right, would be the previous term. And A sub n plus 1 would be what? The next term, right? Yeah, the next one in line. Next term. Okay? Come back here a little bit. Okay. So here's we call them arithmetic sequences, right? Because we added the same amount each time. That sounds linear, doesn't it? Yeah. Okay. So arithmetic sequence was when we added or subtracted the same amount each time, which is linear, is it not? All right, keep that in mind. That's linear. So an arithmetic sequence. So this gives us the first term in the rule. So what does this say? What's the first term? Right? A sub 1, first term, and A sub n, right? Then every term equals the previous term what? Plus 3, right? So you're just adding 3 each time. So let's find the next 3. So let's list the first term. So A sub 1, of course, equals 5, right? What's A sub 2? What's the rule say?
3 minus
5 plus 3, which is 8. Now the third term is the previous term plus 3, so now it's 8, right? And the fourth term is 11 plus 3, which is 14, okay? Know how to do that stuff now? Okay? So they give you the first term, and then they give you the rule. So that was the recursive, right? We also had the explicit, remember?
Yeah.
And there was a common difference, kind of like slope. Like M would be a common difference. Right, so if you kind of did it like this, A of n, right, current term equals A plus A1, the first term, plus D times, anybody remember? N minus 1. Do you remember we had to kind of use the number before?
Oh yeah, and then you would like plug in your.
Do you remember what D is?
No.
It was the common difference. The thing you're adding or subtracting each time. Common difference. Okay? Of course, A1 is just the first term. So let's write an explicit formula. So this is explicit. Okay? So it would be, that should be a semicolon. So, A of n, right? Let's get an explicit rule. So it's like in function notation, equals, okay, from that recursive, A1, right? What's the first term?
Equals 5.
5 plus, what's the D, the common difference, guys?
3.
3 times
20.
20.
Minus
n minus 1. So there's our explicit formula that'll do the same thing as this one, right? So if you guys remember when you had a recursive formula, like the only way to find the 20th term was to just list them all out, right? Remember doing that?
Yeah.
But if we had an explicit, you want to find the 20th term, what'd you do? Now it's like function notation, right? So they want to find which term? Oh, it is the 20th. So a sub 20, right? So a, the 20th term of this sequence is going to be 5 plus 3 times what? Which is 19, right? 20 minus 1 is 19. And what's that give us? What's 3 times 19? Let's see, what's 3 times 20? It's 60. Minus 3 is 57. What's 5 plus 57? 62. So we didn't have to list them all out. I mean, you could donate. Is that kind of coming back to you now?
Yeah.
So those are arithmetic sequences. The hell's getting hot in here? Huh?
I don't think it's hot. It's like,
Because you're wearing Crocs.
I mean, I was freezing.
All right.
Yeah.
So arithmetic. Now we had some other ones that were thrown in there that were not arithmetic, right? Because they were being multiplied by stuff, right? So now we're going to look at those and give them a name. So arithmetic is like so arithmetic sequences are like a linear function, constant rate of change, or D for common difference.
Oh, geometric or like exponential.
The geometric's going to be like exponential, where you have a common multiple. Okay, so a geometric sequence, of course, it's still A1, right? So this just says, instead of n's, we're using i's, right? Any given term, a current term, is taking the previous term times some multiple. Okay? So these, and it's called a common ratio, right? Common ratio is what you multiply by, right? And in arithmetic, it was a common difference, which you add or subtract, okay? So this is going to be like exponential. Okay, well, good. So for each of the, so they want us to identify the common ratio R and give the next two terms. So what are we doing to get from 2 to 6?
By 3.
3, and then times 3. So what's 18 times 3? 54.
54 times 3 is 162.
162. That's all there is to those, right?
So would your R be 3 then?
So the R is 3. Yes. Let's look at part B. What's the common ratio?
Oh, it's going to be a negative number. Negative or 5. It's negative 5.
So times negative 5 gives you negative 20.
Yeah.
Does it work here?
And then
What's negative 20 times negative 5? Positive 100.
So negative 500.
And then times negative 5 gives us what? Negative 500
And then
times
2,000.
negative 5.
Or, yeah.
Negative times negative 2,500. Right? So what's our common multiple R?
5.
Negative 5.
This one would be divided by 2.
Well, let's not do this. Let's keep it as multiplying.
Half.
So times what again?
1
1/2
half.
times 1/2 times 1/2 gives us
2.
2 times 1/2 is 1. So the common ratio, I should say here, is 1/2. Okay? So if we were doing an exponential function, wouldn't that be the b inside the parentheses? Right? Okay? All right. So let's look at a rule for the recursive, right? Where they give the first term. They're using a different notation now, right? What's the first term in this one?
3.
And then we find each following term by doing what to the previous term?
Multiplied by
So the R is 2. So that's the rule, right? So let's find the second, third, and fourth. Let's write down the first term, which was what? B1 equals 3. So B2 equals 3 times what? 2. Okay? B3, I'm switching notations here, I guess, but either way. Equals 6 times 2, which is, and then B sub 4, I should have stuck with their notation, but is, equals 12 times 2, which is, okay? So that looks exponential, doesn't it? So geometric sequences are really exponential, aren't they?
Yeah.
Okay? So let's try and get a value for B of 10 and B of 20. I don't really want to write them all out.
So we can just do the.
Why don't I do this? An explicit, yes. How about this?
Oh, yeah.
Well, now hold on, right? Hold on. One little catch here. See where I wrote x to the x power? Maybe I'll use n. Let me use n. Like to the nth third. Okay? Actually, I'm going to do it this way. That's why we do math in pencil. How about,
Minus 1 equals AB. Good. My wife. Or and plus 1. No.
oh, I don't want to use b. See the b? I don't want to get confused with the b's. I'm just going to use y. But now, look, to the n, right? You know it's not really going to be the n. This has got to be times the previous term, doesn't it?
Yeah.
Remember up here?
1.
Yeah, remember up here? It wasn't times dn,
It was
times the previous n minus 1. So whenever you go to this, you have to do the n minus 1, right? Because look, the second term was taking the 1 before it, right?
Yeah.
The third term was using the result of the second term, right? The 1 before it, so n minus 1, right? So we say b of n equals, what's our multiple, the r? 2 times, oh wait, no, the starting one, sorry, scratch that. What's the starting amount? 3. And what's our common ratio? 2 to the n minus 1. So now we can find b of 10 and b of 20 real quick, can't we? 3 times 2 to the what? To the 9th, right? The one before the 10? Like the term before the 10? And what's that give you guys? No. Well, 3 times that. 3 times that. 1536, right?
17.
And how about b of 20? It's going to be 3 times 2 to the what? To the 19th. 20 minus 1. Should be a pretty big number, eh?
157,286.
All right, what's that number?
1572.
What's that number?
1,000,000.
1,072,864. Okay? So that's a geometric sequence, and it's exponential. You just got to remember to do to the exponent minus 1. Okay?
That's
It's 2 what?
number.
Let's move along here, see if we can enhance the understanding. All right, here's a, so this is interesting, actually. Well, no, not this one. It is kind of. You just won a strange lottery. So, the lottery promises to give you money each day for a 30-day month in one of 2 ways. You have 2 options to collect your money from the lottery winnings here. Here's your first option. You can get $1,000 on the first day, $2,000 on the second day, 3,000 on the third. Right? Get the idea? Is this going to be linear? Yeah, well, really it's arithmetic, which is linear, yeah. Adding the same amount each time. Here's the other option. Let's see which one you guys might prefer. You can get 1 cent on the first day, 2 cents on the second day, 4 on the third, 8 on the fourth, etc., right?
For life, like.
For 30 days. Each one of these goes, so you get an extra 1,000 a day for 30 days, right? For a whole month. And 1 penny, then you get 2 pennies and 4 pennies the third day, right?
I'll take option 1.
So wait a minute. What kind of sequence is this option 2? Geometric, which is really what? Which is really what?
Doubling.
Exponential. Right? It's getting doubled every day. Let's only start with a penny. Which one do you guys think you want to take?
Option 2.
So you just want the pennies?
I would take option 1. It's
You
double.
take option 1?
Yeah.
Okay, so Tegan's going to take
But
option
you're
1.
getting an
Emily's
extra
going to-
1,000.
I'm gonna take.
Yeah.
You're getting that original
I'm gonna
plus
take option 1 as
the
my
day.
bank account so I can get interest.
So you're getting.
Well, that's not a bad
You're
idea.
getting 1,000,
Okay.
and then you already have that 1,000.
Because that's also
Times
exponential.
again.
Okay, well, let's work out these 2 options then, right? So let's look at option 1.
Yeah.
So let's write a recursive definition, or not recursive, explicit. Okay. So any given term and any given day, right, is going to be, what's the starting amount for option 1? 1,000 plus, what's the common difference, D?
1,000.
Another 1,000 times, well, not n, but
30.
n minus 1, right? So is that our function there?
Yeah. And then your other one would be 0.01.
Well, let's figure out. So we want to see what you'll get at the end of the 30 days. So A of 30 will be 1,000 plus 1,000 times what?
30, 29.
29. And tell me what you get for the 30 days in this option. How much money?
Where'd you get 29 from?
N minus 1. My N is 30.
30 minus.
So 30 minus 1.
$30,000.
You get $30,000? Hey, it's not bad. So it looks like you guys that chose option 1 are doing pretty well, yeah?
Going with 2.
You're still going with 2? So you remember something about the graphs we did yesterday, didn't you?
No. I know, yeah. That's what I was
Oh.
thinking about. I was like, but I just rather have.
Yeah.
I never know how to go quicker.
Let's take a look at option 2, okay? Let's write this up as an exponential. A of n, what's the starting amount?
Equals 1 penny.
0.01, right? What's the multiple?
2.
Times 2 to what power?
N minus 1.
N minus 1, right?
Yeah.
Okay, so let's see what A of 30 is here. 0.01 times 2 to the what power? 29.
It's going to be a lot more just knowing. Well,
How much money are you getting?
It's 5 million.
Over $1 million.
You're getting $5 million. And you guys really sat there and said.
Was it 709?
70912.
12 cents. Ho ho, yeah? Which one do you want to take now? The one that's the penny the
one
first
that
day?
I chose. I knew,
Okay.
I knew it. That's what I was thinking about, but I was like,
I'm going to take this one. That's what I'm going to do. So, like, before you guys had this class, you might have all just taken the first option, wouldn't you?
No, I probably still would. 'cause I
Because you only want 30,000 and not 5.3 million?
Wait, mine says,
It's not really worth anything.
Wow.
All you gotta do is buy stuff with it. It's not really. Money's really just a piece of paper.
it's not really
It
paper.
has value, it's got value, right? You can buy things.
Yeah, it's the only way you can get it, so you gotta have it.
This little green
Yeah,
paper
anyway.
is a bit more expensive because it has a 5 printed on it. This one is less expensive because it has a 1 printed on it. You see
Sure.
what we did there?
Yeah, so,
Yeah.
yeah, you have to think about what is the value of our currency based on. It's called fiat currency, it's kind of semi-fiat. It's
Oh, what
called.
now, where?
Because we're not on the gold standard anymore, but I'm not gonna get into this. You guys take my finance class in a couple of years. Anyway,
I will,
I heard that you talk crap about us in your finance class.
no, do not.
Okay, all right, I see.
Okay, exercise 5. For geometric sequence, geometric is really like what?
Exponential.
Exponential. So there's a common ratio or multiple. Defined by it's recursive, isn't it? They give you the first term and the rule to follow, okay? So let's plot the first 6 terms in here. Well, let's list them out. We know A1. So what are we doing each time?
Multiplied by a half.
Okay, so we take that 16 times a half and get what? 8. So what's the third term? Everybody. Everybody. What's the third term?
4,
Everybody. What's the fourth term?
2,
And the fifth term?
1,
The sixth term?
0.
A half. Wow. Is that what they wanted? First 6. Okay.
Oh,
What's the seventh term? What's half of a half?
wait, where?
Quarter.
Because I just want to know if you know.
Quarter.
Quarter, thank you. Okay, now we're going to plot these, yeah? So n on the bottom, right? So 0, 1, 2, 3, 4, 5, 6. How high do we need to go? Up to 16. How many lines would? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. Yeah, we can do them all. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Now I'm going to ask you a question. We're going to plot these points. Listen carefully before you do it. We'll be drawing a smooth curve through them, through the line. Will they be connected, all these points? Hmm? Remember, a sub n is its place in line. Is there anything between the second place in line and third place in line? No, right? They're discrete. Right? So this is one where you don't connect with the line. So let's go ahead and plot these. One, yeah, we got that. 2 is 3, 2, 8, and 4. Yeah, well, it's exponential. 2, and then 1, then 1/2.
Exponential.
Okay, but am I going to connect these with a line again? Not in this case, right? Because at these ends are its place in line, right? Like if you're in the lunch line, if you're fifth in line, and there's someone fourth in line, there's no one in between you. Otherwise, they'd be fourth in line, right? Okay?
No, there's like an uncountable decimal, like,
Yeah, well, there's 2
you would
kinds.
never be able to get your lunch.
Right. You're touching on the 2 different types of infinity that there are.
Uncountable.
There's countably infinite and
It's gotta
uncountably
end in
infinite.
it's gotta end in a 1 somewhere.
So the infinite number of numbers between integers, you can never find the next one.
The next one or the
It
next
just
one?
goes
You
on.
can't find the next,
Forever.
like if you're at like 1.1, you don't know the next number at, you can't count it to the next number. Because the next number would be so infinitely small above 1.1, keep going out decimals. There's no next number. It's uncountably infinite in between numbers. Okay, so we got to read this question. All right, here we go. I think maybe you'd be onto this one now. Possibly.
Both at the same time. What?
Read the Regis question.
This first term is 5.
It's a common ratio, so you know it's geometric, but then they said geometric. First term, I'm going to call this I sub 1, instead of using A's or N's, right?
You have to figure out how you're getting from 5 to 2.
Yep, and the third term I'll call I3. Third place in line is 245. All right?
Multiplying by 49.
Maybe, but that's from the first to the third.
I think it might be something.
Maybe.
I don't know.
Let's think of it this way.
49 and a half.
The first term.
Subtracting 245, subtract 5.
What are you doing?
I'm going to write my geometric.
You can please stop with B.
The first term is 5, right? Times some multiple to what power? Because we know the first term is 5. Right, but what power will this be?
And minus 1.
N is
I
1.
minus 1.
That's a 1.
I. Plus
What's the first term?
5.
5. So I need the first term to be 5 times something that'll equal 5. I need it to equal 5. What's my exponent going to be on that multiple?
0.
Ah, 0, because what's b to this, anything to the 0? Okay, and 5 times 1 is 5. Now let's set it up for the third term, guys. So the third term, I sub 3, is going to be 5 times b to something is going to equal, what, 245? So b to the what? By the way, it's going to be n minus 1, isn't it?
Yeah.
Right? So
I minus
5b to the what?
I minus 1, right?
40.
3.
3 minus 1. 2. Right? We have an equation we can solve now for b, the multiple.
Yeah.
See what I did there? No? 5b squared equals 245. How do I solve that, guys? Let's start by dividing both sides by 5. You get b squared equals what? 245 divided by 5 is 4. Is that our answer then?
No. Just to do the 2, don't you?
Now, how do I undo squaring, everybody?
Divide.
No! What undoes squaring?
Square root.
Square root. So the square root of b squared is going to equal the square root of 49. What is the square root of b squared? B equals 7.
No, that's how you work.
Is that what I did there?
Yeah.
So it's choice 1. Now this I wouldn't be able to solve for b, would I? Right? But I had this third one here. All right? Because I know the third term, it's going to be 5 times something to the second power, the 3 minus 1, n minus 1, right?
Is this going to be a question on our test?
Is it on your review?
Yes, it is.
Okay then.
Yeah. It's on the back.
So, I mean, there it is. Let's do it, okay? All right.